my name is Danielle Olivares, and this is my report on Pseudomonas aeruginosa for medical microbiology. And I chose this bacteria because I found it particularly fascinating how difficult it was for doctors to treat, and just how hardy it is, and the very interesting complications that arise when it's contracted. So, as we can see here, this is, well, let's start out with this little guy. I think he's a great representation of Pseudomonas aeruginosa. He is green and splotchy, and he is covered in sticky mucus, sticky blue mucus. And I think he's a great mascot here for us. But, so this is a typical Pseudomonas aeruginosa bacteria. It has a capsule. It is gram-negative. It is aerobic, although it can live with very little oxygen, another thing that makes it difficult to kill. It has a polar flagella. Most reputable sources say a single flagella, although sometimes it can be found in the middle of the side of the bacteria. And it has a vesicles. It has its DNA nucleoid, ribosomes for RNA production, and plasmids. It is, here's the cell membrane, and it also has a biofilm, which I represented here with the green. It isn't, the bacteria lives in the biofilm it produces. So, some characteristics of this bacteria are that it is gram-negative and it's aerobic, but like I said before, it can live in very little oxygen. It is small, 0.5, 0.8 micrometers by 1.5 to 3 micrometers, and that's much smaller than the typical human cell. As I said before, single polar flagellum. It is ubiquitous to many habitats, and it can live in soil, it can live in water, it can actually even live in distilled water. But it lives on our skin also. It lives on many animals. And it's only dangerous to the immunocompromised and if you have an injury that it can creep into. It is fluorescent under UV light, which is really, really interesting. And it's incredibly hard to kill. So here is an example of the way that one of the ways that this bacteria presents, which I found really, really interesting, what they call an egg yolk, where the bacteria, you can see the green inside, but then its film goes outward and makes it look like an egg yolk. And this is an example of just what this can do. And at this point, I just want to focus on the blue areas. And this is piocyanin, forgive me. And it is one of the another very interesting characteristic because while it makes it blue, it also, one of its other components, piocyanin, is a siderophore, and it acquires iron from a host. And that's one of the other reasons for its blue pigmentation. If anybody has ever seen the color that rust leaves on copper, it's very similar, and that's where it got its name. I move on to its virulence factors here, and what makes it just so hard to kill, and what makes it such a big problem in hospitals and for the immunocompromised. Well, it has a highly impermeable membrane, so getting things through it to begin with is very difficult. And when they do manage to get through, there are many efflux pumps to be found. And these efflux pumps are the mechanism by which this bacteria takes antimicrobials and spits them back out. This is a little bit more of a comprehensive picture here of just how it completes that. You can see the antimicrobial agent here through its porin, which, by the way, this actually bacteria also has very few porins for the antimicrobial agents to get through in the first place. That's another reason it's hard to kill. But if it does get through both its phospholipid biolayers there, it comes through here through what they call a transporter, and with its enzymes here, the efflux pump just spits it right back out, and you have an extruded antimicrobial agent that will do nothing to destroy the bacteria. So, as I just mentioned, there's a reduction in porins in the outer membrane. Its lipopolysaccharide has modifications. It will modify based on what it encounters. It has a modification of drug targets. It will modify its drug targets. It will take in a drug and it will modify it to be not dangerous to the bacteria. And finally, we have its being able to, what's called mucoid conversion, which is this mucus, the biofilm, the sticky mucus that causes a severe problem for people with cystic fibrosis. And because of their immunocompromised condition, the Pseudomonas gets into their lungs. And unlike in this poor gentleman's case here, or in other cases of eye infections and UTI infections, in cystic fibrosis patients, these infections usually become chronic. And they're chronic because this bacteria also manages its inflammation properties. So rather than causing a high rate of inflammation in a CF patient, it causes very low inflammation, preventing the body from reacting to the inflammation and getting rid of the bacteria. So rather than expelling that bacteria, like from a viral pneumonia or a bacterial pneumonia, it simply lingers. And there are autopsy photos that one can find online where in the dissection of the lungs you can actually see the biofilm goop that the bacteria has created in their lungs and pockets. And I just thought I'd avoid posting those pictures for this presentation just in case anyone has a weak stomach. This is a photo here of its different virulence factors, what makes it so virulent. As I said before, it's efflux pumps, its low number of porins, LPS modifications, changing the drug targets, and the low membrane permeability and conversion to mucoid. Those all make this a very, very strong and hardy fellow. So, having said all that, I think I will skip to, here is also some of the different body's organs that can be affected by this bacteria. But if a person is injured anywhere on their body, it's just like the fellow in the picture above, it can affect you on any part of your body. But I did find some surprising facts about this that I was very interested in. The CDC lists it as the fourth most common nosocomial infection, and it has an average of 4 cases per 1,000 discharges. I mentioned before about its pigments that create blue pus, which is really interesting and disturbing. How it can acquire iron from very low iron environments. It doesn't need very much iron to survive. And I mentioned before about its name. Its meaning is full of copper rust, Aeruginosa. That's the meaning of that, and it fits it quite well, I think. But the greatest things that surprised me about it were its many positive uses. The secondary metabolites that it produces are vital in the treatment of multiple drug-resistant bacteria. I was really shocked to learn that bacteria can actually help kill other bacteria, but in this case of Pseudomonas, it's pretty effective at doing that. It has enzymes that lead to the creation of, I think it's captopril, forgive the spelling error there, and that's a high blood pressure medication, a heart medication, which helps tens of thousands of people with their heart problems. And this was really shocking, that it produces vanillin, which is used in foods and cosmetics. It was really crazy to learn that this bacteria that can kill people so easily makes vanillin, but it also has a sweet smell, so that would explain that. And finally, its biopigments are even used for coloring agents, which makes a little more sense considering its blue pus and its color that it produces. So those are all the main things that I've covered. I think I've learned about this bacteria. There are some things that are way more complicated than I've glossed over, but that would take a much longer video. So I hope this has been informative and at least entertaining enough for the 12 minutes that I've been talking. And I look forward to any questions that you all might have. Thanks. Bye-bye.